Okay, this is the August meetup of the Nashville Mobile Developers User Group, also incarnated as the Google Developer Group, Music City. This month we have Mike Simmons presenting on Swift. And I don't know if you have any words to say before he goes. Okay, so here's Mike.
Hello. I'm Mike Simmons. Good to see so many people here. I've been a software developer since 1977. Started out on keyboard trim and 96 column punch cards, and then assembler, and
is not on, it's supposed to be.
It is, yes. Oh, yeah.
Ah, good.
Done everything from assembler to COBOL to Objective-C, which I started out in 93 on Objective-C, 1993. And then, let's see. I'll try and talk and do this at the same time. It's not working.
So, are you trying to do mirroring, or
I'm trying to have alternate display.
If you turn on mirroring, it'll.
I don't want to do that.
You don't want to do that?
No, because I want to see the developer.
Oh.
The presentation notes. It's going to take a little while. We had it working earlier, and I disconnected. No, last time it just showed up.
Don't worry, Mike. We're going to edit all this out of the recording. Make
Oh, that's
it
good.
really good.
That's good. Russell, you got an idea on this?
I'm not really sure what I'm trying to do.
Oh, let's see. Here we go. Excellent. Cool. All right. So today I'll be presenting, well, actually, let me tell you a little bit more about my background. I've been at BMI since 2005, and in my present role, I'm Technology Delivery Manager, which includes both iOS and Android applications. Russell here and Joseph both are involved in the BMI mobile effort. Russell on the iOS side and Joseph, of course, on the Android side. Today I'll be talking about Swift, which I'm scarcely an expert on, but hardly anybody is. I know a little bit about it, and I hope to convey the information in a coherent manner. If you have any questions while I'm speaking, feel free to interject, and we'll take it from there. So what is Swift? Well, Swift is a language from Apple designed to replace Objective-C. Objective-C has been with Apple since 1996, I think, when Apple acquired Next Computer Corporation, which was started by Steve Jobs after he left Apple the first time he was fired. It's for iOS and OS 10. It's a scripting language, actually. It looks like a scripting language, but it has the power and speed of a compiled language. It's built upon C and Objective-C. Objective-C is based on message passing, which a lot of people love, but some people really don't care for because it's difficult to adapt to. I don't know how many of you have been exposed to Objective-C. But it's got a kind of a peculiar syntax for calling methods on objects. We won't go into that at this point because this is a Swift talk, not an Objective-C talk. But Swift is being well received by people who really aren't that crazy about Objective-C. Swift is also influenced by Haskell, Python, Ruby, JavaScript, Rust, a number of other languages, and the emphasis with Swift is on safety and a clean, modern syntax. Why Swift? Well, OS 10 and iOS, as I mentioned before, are based on Objective-C, which is just C with messaging. And C has been around a long time, but it's over 40 years. It's kind of showing its age. And a lot of languages have come out in that time that are improvements upon various thoughts that have implemented various ideas in compiler theory that C just can't really implement. The new language, Swift, sheds all the constraints of C compatibility and allowed the Apple compiler team to come up with some cool features. In particular, safer programming patterns and more modern features. Swift still uses automatic reference counting, which is for object deallocation when objects are no longer needed. It's fast and deterministic, unlike garbage collection, which had been used in the past. But the problem with garbage collection, I don't know how many people are familiar with that, but it can kick in at inopportune times and slow performance down without any warning, whereas automatic reference counting is always operates the same way, so it's very predictable. What about Objective-C? Well, it's going to be around for a long time. The frameworks for all of Apple's OS 10 and iOS are written in Objective-C or C, and there's a huge number of them, and they work just fine with Swift. So there's really no need to rewrite them at this point. However, over time, they will be rewritten, but it's probably going to be several years. However, Swift does play nicely with C and Objective-C, so there's really no real incentive to rewrite them at this point. To show you the difference between Swift and Objective-C and C++, just as a comparison. This, as many of you will recognize, is a simple Objective-C program that does the typical hello world. And as you can see, it consists of a little boilerplate. Not terrible, but there's a lot of wrapper code around that. C++, very similar. Again, just says hello world, but there's some wrapper code around that too that is pretty critical. Whereas with Swift, that's it. Now, not every program is going to be that way, of course, but it gives you an idea of the brevity that can be achieved with Swift. And in general, you can really condense a lot of code through a lot of the features that have been introduced to Swift. Is Swift an improvement over Objective-C? Yes, I'd say definitely so. It's less wordy, and as we all know, the fewer words you have to write, the fewer mistakes that you're going to make. It has rigorously enforced type checking, which Objective-C didn't really have. Instead of catching errors at compile time, it caught errors primarily at runtime. While that allowed a great deal of flexibility, it also could run into problems sometimes, because some problems might not be caught for a long time. And of course, if you have to go through the compile cycle and run cycle and then find your errors, you're going to be going through that iteratively, and it's going to take more time. Whereas if you find them right away in the compiler, it means that there's somewhat less time spent doing it. Playgrounds. Playgrounds are a really cool feature of Swift. I like them a lot. With Playground, you get to play with Swift as if it's an interpreted language, and as you type in statements. They're executed, and you can see them as they execute. You can change various parameters in what you're typing in. You see it reflected immediately. There's a history of variables that you can pull up to observe the execution, historical execution. There's all sorts of really cool features about it, which I have only begun to look into at this point. We're going to have a demo on Playgrounds at the very end of the presentation. Swift has a more modern syntax, as I mentioned before. Objective-C is a bit creaky. One big thing, to me at least, is there are no header files. I don't like header files. It's just a lot of overhead. Swift does away with them entirely. And it's faster. So how much faster? Well, as you can see here, a comparison of Objective-C and Swift with various sort algorithms. The minimum speed up in the sort algorithms is 6.8 times, and the maximum is 18.4 times. Now, while this won't be represented across the board, it still, I think, is indicative that Swift will be faster than Objective-C. And one can say probably a lot faster in a lot of circumstances. So that's going to translate directly into speed improvements on iOS as well as OS X, particularly on iOS, which is running on much less powerful microprocessors. Swift's new language features. I'll just briefly mention what each one of these is, and then I'll cover them in more detail as I progress in the talk. But optionals are used when variables may or may not have a value. Generics allow a method to operate on various data types. Inferred types allow a developer to assign a value to a variable and let the compiler figure out the type, which is a very nice feature. Tuples allow for passing of multiple values back from a function, among other things. And one feature that has been mentioned in the past, kind of tongue-in-cheek, but it could prove useful, is you can use any character you like for constant and variable names, including Unicode. As well, classes and structs have functions, protocols, and extensions, and in many ways, classes and structs are pretty much interchangeable. There are some differences, but there are certain times that you would prefer to use a struct over a class, but in general, they're very similar. There's lots more. So what are optionals? Well, as you can see here, optionals are used in situations where a value may be absent. An optional says there is a value and it equals X, or there isn't any value at all. So in this particular case, we have, I can't reach that, but you can see that there's a question mark after X is declared as an integer. That question mark means that X may or may not have a value. In this case, we did assign a value to X, which is 42. So this line here that says if X not equal nil, that's going to be to evaluate true, and that's going to be the value of X, which we see now. If the optional had not had any value assigned to it, then we would have taken this one. So that kind of cleans up your code and makes things easier to deal with, particularly in a lot more sophisticated situations than that. It could be useful, for example, when a property can be there or not be there, like a middle name or a spouse in a person class. Optional binding. Use optional binding to find out whether an optional contains a value, and if so, to make that value available as a temporary constant or variable. So in this case, we have, again, X declared as an integer and set its value to 42. And then we assign a temporary value to X. And if that statement succeeds, which it will in this case because X does have a value, the value of X is variable value there. So in this case, it would come out to 2. If there were no value again, it would say X has no value. So optional chaining. Optional chaining is kind of a cool feature too. In this case, we have a person class, and a person can own a vehicle. And then we have a vehicle class, and that has the number of wheels. In this case, we set the number of wheels in the vehicle class to 2. So here we create an object of type person, and that object is called Joe. Instantiate Joe as a person, and we don't, you'll notice, we do not assign a vehicle to Joe. So Joe has no vehicle. Here we have optional question mark right after Joe.vehicle, which means if Joe does not have a vehicle, if Joe does have a vehicle, then we set the number of wheels in the vehicle to, we don't set it, let's see. Oh, sorry. We set the wheel count to the number of wheels in Joe's vehicle if Joe has a vehicle, if that makes sense. So here, because Joe does not have a vehicle, we never set Joe's vehicle. It says unable to retrieve the number of wheels. Conversely, Joe now has a vehicle. So that vehicle is 0. So that would actually succeed, and we would print Joe's vehicle as 0. Probably going through this way too fast, but I think I'll make slides available to you all so you can have a look at it. Generics. Generic code enables you to write flexible, reusable functions and types that can work with any type, subject to the requirements that you define. First, we have, in this example, a structure containing a pair of numbers, both of the integers, A and B. And we initialize, this is the initializer right here. And we have a comparison function. Comparison UV returns A is equal to B, which means that A is equal to B, straight away is up. So we establish a compare, set A to 5 and B to 10, and that would return false. Now that's fine for integers, but if we wanted to do the same thing with doubles, well, we have to create another structure, and we call this double pair. That's the same thing, except we do on doubles. There's a better way to do it, of course, which involves something called a generic, which means that you set up a structure and you use basically a template, which is the template would have T as any type. So that could be, well, any type that conforms to the equatable protocol. So in this case, you can pass in integers, you can pass in doubles, and it's going to respond either way, so you don't have 2 separate types of structs. Any questions thus far? The third types. With Swift, you don't have to actually, you can, but you don't have to. You don't have to actually explicitly set the type of the variable. The top portion, the top one, you say you have their name, we declare it as a string, and we set that string with value. But we also can just say their name equals some string value. In this case, the compiler figures out what you want to do with that variable and sets its type accordingly. That also reduces the amount of code that is written. With tuples, tuples address a problem that is in C, whereas I don't know how many of you are familiar with C. C, if you have a function that can return a value. That can be a simple type, like an integer or a double or something of that sort, or it can be a pointer to a structure that that you then have to currently. With tuples, you can return multiple values. So in this case, we declare a tuple, name tuple, and we just have a first name and a last name. And we set that to. And as you can see, when we print the tuple, it says code. Now, when we want to return a tuple from a function, for example, this function is get weights. We simply return the tuple as a discrete set of values. So it helps alleviate the problem of a single return value. So in C and C++, various other languages too. This is an actual working program. It's probably not one that you would want to write, but it shows you what you can do. It's simply adding two numbers and filling out the results. This form here, which you've seen in the earlier slides, says print out whatever some flows between backslash indication that something needs to be printed out. Another extreme example, which I didn't write, but I actually copied it and put it into a program. That works. The end result is that. So it's kind of fun to play with, but I don't know that you actually want to get too far into something like that. Closures are self-contained blocks of functionality that can be tested. Similar to blocks in C and Objective-C, and to lambdas and other programming languages. For example, Swift's array type has a map which takes a closure expression. So here we declare an array of numbers initializing 1 to 10. And then we invoke the map function. And that is simply a closure. Means multiply the argument by 3. And then returns an array of result. So that's the result of that. Closures are very handy and take a little bit of use to. That is the most condensed form of closure there. Closure. This shows the various ways to gradually condense down closures can be very, very long. They can be quite long. Extensions. They add new functionality to an existing class, structure, or enumeration type. Includes the ability to extend types without the original source code. So in this case, we take the class double and we extend it by two methods. Those meters and those millimeters. So you would pass in a meter of unit of type, a value of type meter, unit meters, and then it would actually invoke that method. So you do that with anything ints or whatever. You don't have to have a source code. That's nice. Query functions. I got to that I don't really understand query functions. Maybe Russell does. He's shaking his head. I kind of understand them, but it's very difficult for me to understand where they've actually been used. But curry functions are named after Haskell Curry, an American mathematician and logician. And the idea is that if you have a 2-parameter function, you can rewrite it as a 1-parameter function that returns another 1-parameter function. The return function takes the next parameter and returns another function. And this continues until no parameters remain. And the last function returns the return value of the original multi-parameter function. Now, if that makes sense to you, that's wonderful. It requires a little thought. So here's an example of curry. The first top line, the first segment says simply a method that adds 2 values and returns the sum of those values. The curry add is here. That's what I was saying. It returns the value of x and then actually revoke it as 10 and then another. Much the same with this one. It's a little more expensive. Frankly, again, I don't understand completely, but I'm just presenting it here so that we get a better idea as to what curry functions are about. Has anybody ever used curry functions?
There's similar construct in C++ and state example. What you do is you use that to function or function to that's something set. It's a way of sort of reusing habits.
So you can chain essentially just
keep going until and then that's a function you can save and use later on. So for example, you call curry add and pass it on. They can call that all the times you get values for one.
right.
We all just add.
Yeah, that's essentially what's going on. If you're curious, there's and you can look at this later in the slide so you can do a good reference on that. Here's an example of a struct, simple struct. It's called animal struct. It has the species, which is a string, and initialize sets species to a certain value. It has a single method, speak, which will announce the name of the species that it's set to. So in this case, instantiate an object called sheep. So class animal and species is set to sheep. So sheep. Here it says sheep. So it shows that you can actually have methods on structs. Protocol is a blueprint of methods, properties, and other requirements that suit a particular task or piece of functionality. You can mark methods in a protocol as optional by preceding the func keyword with an optional keyword. In this case, I declare a protocol called speaker, and this simply has a function speak. Now, it doesn't implement a function. Whoever adopts that protocol is required to implement that function. So in this case, we have an empty class called animal. Doesn't matter. But, we then have fast dog, and is a type animal and it conforms to the secret protocol, which means that it will be required to implement the method speed, which it does here. Speed. So you say a dog, you send it here as a dog, a fast dog. So protocols really are just a way to well, they're useful for delegation. You can say that a delegate class conforms to a certain protocol, and then that class will implement whatever that protocol prescribes.
Can you have multiple animals, either fetus do describe them together?
Yeah. Yeah. It can comply with any of those different protocols. Mario playground. Well, let's see. Any questions so far? I know that was pretty fast.
Just a question on my side.
Huh?
Given your experience with the class dog right there, is it inherent compatible, like you're saying? It's a class.
Yes.
The Objective-C and Swift and you have more than one instance, inherent from multiple.
No.
Just one, not really. It's not.
Yeah. Single inheritance.
Okay. So speakers is the protocol, where you can you're doing things with it here, right? Is that
Yeah.
just what I'm
Yeah. And as she said, you could comply with any number of protocols. Yes.
How about, I've seen your definition, your discussion on structs and classes. Can you both construct a class in program? Is it just a class?
I would assume so, yes. Yeah.
So could you have a single protocol included by both a struct and a class?
Sorry?
No.
Did
If you do either, you can do what you said.
Okay. Yes.
So here we have the protocol defined in this file.
Mm-hmm.
You said it doesn't use include files. If you have other protocols that were defined elsewhere, how do they know about? How does it know what was open? You have to define everything in one file.
No, you have multiple files. And somehow the compiler recognizes that. I don't know how. But, yeah. And Swift also has namespaces.
It wasn't in the module. Anything inside a single module.
No.
All of your source file, when you go to see all of your definitions for all of your source. You go and import something, say the strike kit library. You have to import that module into your.
Oh.
So it's not really include, but it's like an input frame.
Oh.
Let's see. Oh, yeah. So, there it is, now. Okay. Well, here we have the playground. You can see there's nothing there. Yeah. But you see a line number over there. So I'll give you a simple little demonstration. That's one thing that I will need for this, is just importing the Cocoa frameworks. So let me set up a range.
Do you have the control zoom turned on where you could zoom in your screen a little bit?
Oh, I can. So, trying to put that right. How do you do that?
you have it turned on, you hold the hold the control bar down and control button down, and zoom the 2 fingers on the touchpad.
It's not working.
Never mind, you're up.
Okay. Hopefully everybody can see it reasonably well. So here I set a range from 1 to 2,000, which so you can see it's evaluating the instruction. It ran through that loop 1,999 times, and we will have a look at what it produced. So that shows the values, and it's a simple sine wave. I'm not claiming that it's mathematically correct, but you see the results of that. If you want to play with it some, you say, well, let's see what happens if I just do 1,000 cycles. So it reevaluates for you on the fly. And if you want to do cosine, for example, instead of sine, if, let's say, you want to experiment with the URL. Thank you. So we reevaluated everything in there. And this little I here means that you can have a look at whatever's in that variable. It actually will show you the contents of that variable, which points to that URL. There are a huge number of things you can do with the playgrounds. If you look at the developer.apple.com, the WWDC videos, it shows there's one on playgrounds, an hour-long presentation on playgrounds, and they do some pretty amazing stuff. I think for me, it's going to be really exciting to play with playgrounds, and I think also for new developers new to Swift or new to programming in general, it's also a very easy way to learn programming as well as the Swift language, because you can just jump in and start typing and see the results of what you're typing immediately, rather than having to go writing stuff, compiling it, fixing the bugs, recompiling, going through and seeing it run, etc. It's pretty neat.
So is this tool you're using special to Swift, or is it?
Yes.
Yes.
This is a Swift playground proper. If you xcode also, yeah, that's a good point. Well, xcode is the development tool, and yes. Now, when you're actually writing a full program for iOS or OS 10, you'll use the facilities of xcode proper, which means that you do go through the compile and run.
Sure.
Compile, let them run scenario. But if you wanted to try something really quickly and see the results of that, then you could just copy and paste your code into the playground and tweak it, play with it some, and perfect it, and then put it back into the xcode development environment.
Okay, is it sort of like a plugin that xcode is that does this, or is it all just a tool?
The playground?
Yeah.
It's built into xcode, in the new version of xcode. Anything you can think of to add?
Good question.
Uh-huh.
We call this a graphing tool in the website review. What is it called? Which special name for it?
They're just features of the playground. So this.
Too easy for us. We don't get it.
Yeah. they're just part of it. So, for example, this. So, in this particular case, you have the option of, again, looking at the value of the variable, which in this case it simply says it's gone through it 999 times, the loop 999 times. And then you want to get the value history, so you just click that and display it. Also, if you want to go back in time and look at various discrete values, you can do that. The value of each one.
Do you know if it'll do anything in a 3D graph? Like if you update a tuple, will it maybe put a 3D in there?
I don't know. Pretty sure it's only 2D graphics. Well, you can display user interface elements and various other things. It goes well beyond this. But again, you don't want to write giant programs, but you can write hundreds of lines of code, as you see if you go to the presentation. They do some pretty sophisticated stuff.
It's kind of like having like a oscilloscope in your lab. You can just quickly see your code unit.
Yeah, and if you again want to just idly play, that's the way to do it. You can change color. You can play with colors. You can just a wide variety.
Did you say you could put Objective-C into
Just
So you said that for writing applications, you still needed to use Objective-C?
no,
Okay.
no.
So we're going to throw Objective-C away. So what about
You can't.
for data and all that stuff? Can you play with that in firmware?
Yes,
Okay.
but through Swift.
Through Swift.
Swift invoking those.
And so, do they, the function names the same? I mean, like the messages? I mean,
There are interfaces that you invoke, and for all practical purposes, they're specially rewritten for it. They're automatically bridged to Swift. So instead of invoking it as an Objective-C method style, with the brackets,
yeah.
it would conform to the Swift function technology. So to Swift, they would look like functions, but you're under the covers, it's actually invoking the class. So that's all transparent.
And you said you can do all the user interface stuff as well.
I wouldn't say all, but you can do a number of things with it. I personally haven't done that. That's my understanding, isn't that your understanding, Russell?
Well, I mean, your buttons and your slides and your...
All that.
Yeah.
Those user interface elements.
So you can put animation.
You can just plug in my button there.
But, now, that's how you get something. If you finish playing in the playground, you want to put this on your device.
Playgrounds would be great for algorithm development. And then copy and paste the code out into your main application.
It's still in Swift.
Which,
Yes.
in this case, it would have to be in Swift because you're copying from a playground.
But, for example, you would, as I'm showing here, you would have a project in xcode that, actually I'm not. Select your language as Swift. setting up a new Swift project and telling it just to so this is what your project would look like, and it would be a full-scale xcode project. If you decided, for example, that you wanted to test out some sort of theory without having to go through the file and run scenario, you just copy and paste this into the playground. Play with
It
it
was
and you
never
copy it
meant,
back.
it was never meant to be a simulator or whatever, like our iOS simulator. Not that.
No, no. And in fact, you can't run it with any physical device. It just is it's for simulation, but you don't want to do the
It's
full-scale
just
development.
snippets, it's just little.
Yeah. Playground. It's pretty accurate on that. Any other questions? Okay, I guess we're done.
All right, stick around for a few minutes. We're going to be giving away Chromecast and some full-site cards. You go to this link, ICC /NMDUB0804, and we'll have the survey link. So there's a question on there about read charter, read public schools. I forget which one. Anyway, we're trying to get some teachers to help teach 8th graders some mobile development basics. Zach McCormick, one of our organizers, is putting that effort together. If you'd like to know more, please leave your email, and we'll get back to you on that.
I can't see that at all.
That's I'll come back there. And while we're doing this, now's a good time for go around and introduce ourselves. You want to start off, Joseph?
My name is Joseph Banta. I work here at BMI. I'm a generic developer. I do whatever they tell me to do. Right now I'm doing a bunch of PLSQL manipulation, moving data around. When that work goes away, I'll be back on Android and maintaining and developing new Android code for BMI.
My name is Jenna. I am an IT recruiter with Connections Group, and hi. Thanks for coming.
I'm Ed Jones. I'm the Sergeant Arms of the user group. I do mostly IBM development of the portal system now.
Hey, I'm Jason Floyd. We're doing our own development.
I'm Brandon McQuarrie. I'm an IT consultant. I work for a couple companies in the area. And mostly I do, well, I do full stack development, which was all the last few years. It's been all front-end stuff, so I JavaScript, jQuery, that's about it.
I'm also Cook. I've been at BMI about 5 years. I've been doing iOS development for about 4 years now. I'm currently doing solar searching. I'll be back